On question 1, the feasible region was already graphed for us, but now we have to graph it ourselves. So we have a couple steps here. We have to graph the lines, then we need to find the shadings, and then the intersection of all of the shadings is going to be the feasible region. Then we need to find all of our corner points. Then we need to plug in the corner points into the objective function so that we can find our maximum or minimum value. So there's a lot of calculator steps here, so this is kind of a good table to refer back to. The shadings, we want to use the upper triangle for greater than or equal to, and the lower triangle for less than or equal to. And the feasible region is the region where all shadings occur. So it's the intersection of all of the shadings. But because we have so many lines, we can have quite a bit of different shadings, and it can be actually kind of hard to see. So I actually like to use the reverse, where we do the lower triangle for greater than or equal to, and the upper triangle for less than or equal to. And if we choose this method, then the feasible region is the region where there is no shading. And this is actually easier to see. So I'll show both methods on this question. We want to find the corner points, so we're going to be using the intersection command, which is second calc and then number 5. And then we have to select the first line, second line, and then make a guess. So I would say that this takes the most amount of time of any of the steps on these questions. So actually most of the time of these videos is just devoted to finding the intersection points. And it can be kind of tricky, and it definitely requires a lot of patience, but once you get a lot of practice, it's not too bad. So we're going to have to be selecting lines, and the up and down keys, this changes the line that the cursor is on. So you're trying to find the intersection point of different lines, and you have to select which two lines you're trying to find the intersection point of. But if you have 5 lines, you have to pick the right ones. So pressing up and down changes the line that you're on, and it actually tells you which line you're on in the upper left hand corner. And then pressing left and right, this navigates the current line that you're on. And you can see the coordinates to the cursor on the bottom of the screen. And then we also have to find corner points on the y-axis. And if this happens, we want to do second calc and then number 1, which is the value command. And then type in x is equal to 0, and then we can press the up key to scroll through all of our points. Lastly is the window. The window key opens the menu which determines how far we are zoomed in on the graph. So it doesn't change the graph itself, it just changes how we're viewing the graph. So y max, this is how far up it's looking, x max is how far to the right, x min is how far left, y min is how far down. If this were a touch screen, you could just swipe to the left or swipe to the right or pinch in and out, but it's not, so we have to manually enter in the window. So the default is the standard window, which is -10 to 10, -10 to 10. For this section, -2 to 12 and -2 to 12 will work for most questions. Number 2 says, maximize z is equal to 6x plus 4y. And this is subject to all of these inequalities. So my goal is to pick an x and a y value and plug them into this equation and try to get the largest value. However, those x and y values need to be true in all of these inequalities. So I want to graph all of these inequalities to make my feasible region, And then I want to find the corner points because I know that the maximum has to occur at those corner points. So I need to graph these inequalities. So I need to solve for y. So on the first one, I'm going to subtract 5x from both sides. Then I'm going to divide by 2. So this is going to be my y1. Then my next inequality, I want to add x to both sides, and then divide both sides by 2. So my y2, or my second inequality, is y is less than or equal to 1/2 x plus 4. And then my third inequality is y is greater than or equal to 0. So I can't actually graph on the calculator the x is greater than or equal to 0. We have to do that by hand. But the other three I can graph. If I go to the y equals menu on my calculator, in my y1 I can type -5/2 x plus 10. In my y2 I can type 1/2 x plus 4. And in my y3 I can type 0. So these are my three inequalities. Next I want to go to the window button, and we're going to use -2 to 12 for the x-min and x-max. Again, that is the left and right of the window. And the y-min and y-max are going to be -2 and 12 as well. And that's the bottom of the window and the top of the window. So I should be able to see my graph using this window. And then if I press graph, this is my graph. So now I'm ready for the shading. So I'm going to show both ways. I'm going to show the actual way as well as the reverse. So the actual way, this was y is less than or equal to -5/2 x plus 10. And y2 was y is less than or equal to 1/2 x plus 4. So because they're less than, we are shading below, so it's the lower triangle. And then we had y is greater than or equal to 0, so we are shading above, so it's the upper triangle. So then if you press graph, this is our picture. So our feasible region is right here, although we have to manually cut off this section here because x has to be greater than or equal to 0. So we have to be to the right of the y-axis. So this would be my feasible region. So it's the intersection of all of the shadings, but again, with the x is greater than or equal to 0, we have to know that this part here is not part of our feasible region. Now if you do the reverse, I think it's a little bit easier to see. So instead we do the upper triangle for when it's less than or equal to, and the lower triangle for when it's greater than or equal to. And then if you graph, the feasible region is where there's no shading. So that is this shape right here. But again, we know that we can't be on the left of the y-axis because it says x has to be positive. X is greater than or equal to 0. So my feasible region is that shape right there. So let's graph that shape on our paper. It looks something like that. There are my corner points, and I'm going to shade in the feasible region. Now, before we find the corner points on the calculator by using the intersection command, it's actually going to help to remove the shading. So if you go back to the y equals menu, you want to move the cursor to the very left and change all of these back to the original line symbol. So then if you press graph, we go back to the original graph. Next I want to use the intersection command. So I want to press second calc, or you can say second trace, and go to the calculate menu, and then number 5 is the intersection command. So that will take us to our graph, and we need to declare our first curve, second curve, and our guess. So we need to declare what two lines are we trying to find the intersection point of, because we have more than two lines. So let's find this intersection point first. So I want this to be my first line, this to be my second line. And again, pressing up and down, that changes between lines. Pressing left and right navigates the cursor on the current line. So on my calculator, the cursor is already on the line that I want. And we can see in the upper left-hand corner that it's on my y1. So that y1 is referring to the lines that I typed into my y equals menu. So I want to press enter. So this is now locked in as my first line, and then I want this to be my second line, and the cursor is already on it. So I can just press enter. Then I need to make a guess, press enter, and then it calculates the intersection point. So that is at 2, 5. To find the next intersection point, we need to press second calc again, and then select intersect. So now I'm trying to get this point right here. So I need to select this line and this line. So right now my cursor is on y1, so I'm going to press enter. So this is now locked in as my first line. But the cursor is now on this line, which is y2. And I don't want it on that line, I want it on this line, which I had entered in y3. So I need to press down, and then it moves it to y3, which is the axis. So it already has this as my first line, and now I want to press enter to lock this in as my second line. So press enter, and then we can make a guess and press enter, and then it now has the intersection point, which is 4, 0. Our last two intersection points are on the y-axis. So when a point is on the y-axis, we actually have to use a different command, and that is the value command. So second calc, and then number 1, which is value. So that will take us to the graph, and we need to type in x is equal to 0 and press enter, and then it will take the cursor to one of our points, and if you press up or down, it will scroll through all of the different points that are on the y-axis. So 0, 10, 0, 4, and 0, 0. So the ones that we want are 0, 0 and 0, 4. Now that we've found all of the corner points on the calculator, I want to label them on our graph. So 0, 4, 2, 5, 4, 0, and 0, 0. So again, just to recap, any point in the feasible region satisfies all of these constraints. However, the only points that we care about in the feasible region are the corner points, because those are the candidates for the maximum. So 0, 0, 0, 4, 2, 5, and 4, 0. So those are the points that I want to plug into the objective function. So 6 times 0 plus 4 times 0 is 0. 6 times 0 plus 4 times 4 is 16. 6 times 2 plus 4 times 5 is 32. And 6 times 4 plus 4 times 0 is 24. So the largest value that we get here is the 32. So that is going to be our final answer. The maximum is 32, and this happens at 2, 5. So this equation can get no bigger than 32.